Okay, this time. Volume check. Alright, we're good. Let's go. Continuing C-style arrays. Uh-oh. What is this? Oh, wait, no, we're on the same. Okay. What is this? Second. Oh, these were the... Excuse me. These were the two ways of passing them. And one was passing... Oh, okay, we did both, I think. There's another fucking ant up there. Where are they coming from? The corner of the wall. They know it. Damn it. Oh, I have a receipt that's begging to taste this ant's blood. Keep crawling, little man. Can I reach you? Come. Oh, it's over for you, buddy. Okay, that ant is gigantic. Done. You're done.
Death has found. The ant is dead.
Okie dokie. Dead. Let's go. Crumpled him up in a receipt. Fucking big ass biting ant. This big black and red one. I think my pants pinched my leg hair earlier because my fucking legs are hairy. Born in the north, yo. But I thought it might have been an ant, so you know what? That was to get him back. So the two options are to pass with the C-style array to the function, its size. So passing it in as another argument, receiving it as another parameter, probably a size t. Perhaps as a non-type template argument, so we can use a static assert to make sure that the size is valid for whatever we're doing. If our function is, oh my god, another one. If our function is doing something to the same element each time, which, I don't know, feels like maybe weird, but I don't know, maybe you just want to print the first element every time. I don't know. Thought I saw another. Alright, well, there is another up there. I thought I saw a third. Keep coming. No, come on, I'm blowing on him to get him to go. He froze. Buddy, what will you destroy it? How about another piece of paper? Okay, bro, can you just move? It's like he paused. What is he doing up here? He's paused. Yo, bro. Oh my god. He's too high up in the corner for me to smush him. Maybe not. Let's try this, huh? I don't know if I can reach that. Yeah, I can. No. Did I kill him with my breath? Oh shit. Alright, well, buddy, you're done. Smush. Is over for him. To make sure I didn't just leak some crazy info. Yeah, I'm good. I don't even know what this is from. Oh. My registration shit. Let's hope I didn't dox myself. Alright. Can I fucking work now, please? Can I get back to studying? That ant's crawling on my wall? Just because the light's on in this room or something? There's not a single edible thing in here, so I don't know what they'd be doing. Okay. So one option is to pass the size with the array. That's boring. Another, slightly less boring, is to build the array and terminate it with a value that we can check, kind of like a sentinel value, but really a terminator value. So, for example, we have what would be a good example? I don't know. I mean, you could say. I think it depends on the array. If the array is like if we have a damage array or a target. Yeah, but can C-style arrays even be what objects can C-style arrays be for? Are they only for fundamental data types? I don't even know. Like, for example, can we make one of strings? Okay, I guess you can. Doesn't care about the data type. That's good to know. Far away. Hold on. Let me get lotion. My hands have been super dry recently. I reordered new lotion, but every time I wash my hands, they're dry from moving. Just enough. I'm basically out of lotion, but at least the bottle's not squirting anymore. No second ant or no third ant. I think I'm good. These fucking ants are big. Okay. So we either build it into the array, so if we have an array of positive things or an array of strings that are, well, I mean, what? If we're talking about the size, we need a terminator value. So yeah, so we could say, let's do one for standard string. And we'll do print targets and increment and print. I think we can do that, right? Yeah. Let me get a little bit of music. I'm feeling it. Feeling a little, I don't want to do clear obscure. I don't want to cry right now. Let's do, no, not my fucking videos, bro. Let's do, let's do this. Let's do this too. Let's do string view. Sure. Please. Let's do. Hmm. I haven't used a for loop like this where I'm not checking a range. I want to try something. Oh shit, this will work. Holy shit. I want to loop this. This is fantastic. Millie's amazing. Great voice, great. Oh, just wow. Instrumentation's powerful. Uh-oh, hold. Well, I'm curious here. So we have these targets. Oh, the problem is we do 0. Excuse me. Which dereferences the pointer to the 0 index. Prints, increments. Excuse me. Does it for the second. Prints, increments, does it to the third. So element 2. Increments. And then, oh, here we go. That's why. The problem is I didn't fucking put target terminator in the array because I'm stupid. The point here is to use this as a for loop. Instead of doing a clumsy while loop where I have int x is here and then while true and then this shit and then we check I'll just do the same thing real quick. Wait, is it actually even easier with a while loop? It might. Oh, it's not. Well, all right. So the point here is, oh no. Oh, well, duh. We're not fucking incrementing it. Hold, no semicolon. Oh, well, also no space. Alright, so you can do it either way. This is significantly longer. I've never done it this way, where we do it while something... It's always been less than, greater than, less than, equal to, greater than, equal to something. It's always been a range, because we're counting, and it depends on I, while I is something. But this has nothing to do with I. It's using I as an index, and we're saying this happens until we basically get told otherwise. So you could have I don't know, you could have a game like Peak, and this is high 5. and you can. I don't know, and you press a button in your character. Like, let's say there's some stupid mechanic where you press a button and your character makes like 4 different faces. And for the first 3 faces, your character will give a high five, but the last one, it will not. Well, you could say, okay, for the first one, make a high five, the second, do a high five, the third, make a high five, but not for the fourth one. Or you could just say, count through them and do a high five for each until you get to one that doesn't. And then it would be boom, 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 and then no, because that's the final one. That example makes, I mean, it makes sense, but it's stupid. AKA our Terminator value. And these guys can be constant expression because they are C-style arrays of characters, technically. Oh, so that's exactly how strings are implemented, pretty much, right? It's an array of characters that automatically gets populated with, and with a, what do you even call it? With a null terminator, like \n or something. And it just reads through the characters until then. So you pass it somewhere, it passes it as a pointer to the first character, and it loops through to print it until it gets to the end. So we could have, I think that's a character. Bum. Oh shit. Fuck, no? Uh-oh, hold. A zero-sized array? Fuck, the size can't be changed. I guess that doesn't work. Okay. Instead, use it as basically a null terminator. Oh, there it is. Here it is. Oh. That way the length of the array can be calculated by counting. Basically, just count until the terminator. Boom. Yes. Oh, and I guess we do count, right? Because we could just say for whatever. For integer I is 0. Until, well, for I is, yeah. Well, yeah. I is 0. For each one that we can iterate through, boom. It counts as 1. So, and then returns. So maybe it starts at 1 actually, and then goes. It works with implicit function calls too. We just iterate until, or we just go through until the end, traverse till whatever the terminator value is. That makes sense. If it doesn't exist, yes, it indeed will walk off and continue going through with undefined behavior for, oh my fucking god. Oh my god, is that the queen? Is this the queen ant? Oh my god. She's going. She's leaving. No. You can't. She goes. She fights with me, bitch. She fights with me. Yes. Come down. Come down. Fuck. Come. Yes. 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 Not on the ceiling, please. You're gonna fall. No. Fuck. Ran back in the hole. God damn it. Fuck. The ants live in there. Maybe that's what I got bit by in my sleep. Trifecta little bite there. I thought it was bugs while I was moving. No idea though. Oh, he's back. She's back and she's mobile. She's mega mobile. Done. Freeze! You're done. Another ant caught. It's fucking ant catching simulator. Okay, I'm gonna take a picture from up there. I'm gonna take a picture really quick. And I'm gonna email the landlord real quick. Should maybe get a picture of it in, huh? It's probably a good idea. Another! Oh my god! Oh my god, this one's a soldier! He's so fast! He's so fast! Oh my god! Dude, he has to die. He's gotta go. He's gotta go! That's the freaking soldier. He's done. Oh my. Dude, he was teleporting. Can I just fucking study? I would prefer studying over fighting ants all night. Oh my god, there's more on the other wall. They're everywhere. Where'd this one come from? Get out! Wait, I hope. Okay, it's getting too hot now. Fuck. I didn't see where he went. There's no way he's not dead. So. Okay. Turn into an ant battle. Jesus. Okay, so it turns out 6 ones. Okay. Let me check my bedroom real quick just to make sure so I don't get fucked on. Okay. Guess I'm good. Sorry, I was supposed to be just studying. Turned into a fucking battle. I did not sign up to play Grounded, buddy. Okay. Let me check. 3-hole bug bite. That is not it. Damn, bro. What are these people getting bit by? What in the fuck are you getting bit by? What is that? It was just clickbait. Okay, I can't. Unbelievable. God damn. Okay. So we can use a terminator. That's how we do it for C-style strings, which are just constant characters. And it converts to a pointer when it's evaluated because it's a, guess what? It's a C-style array. So C-style string is just a, excuse me, const C-style array of characters. Or rather, a C-style array of const characters. They need special handling for terminating. Oh, for the terminating element. It needs to know not to print. Well, yeah, it just needs to check it, sure. And then maybe it needs to, well, yeah, that's it. No, it's fine. And then, okay, it's my hairs. Mismatch, if there's a mismatch, or, oh, there's a mismatch between the actual length, gotcha, and the character. Oh, okay, makes sense, yeah. Because the length is technically 8, right? So the size will not be correct, but if the wrong length is used, but we're not using the length here. We're just going through all the characters until we hit the last element now. I don't know why that matters. And if a semantically invalid value exists, which is often not the case, yeah, because if we have one for integers, especially if we have an array of random numbers, maybe like let's say we have some sort of pathfinding that the enemy generates a random place to go to, a random point. Let's say we do it for the x, y, and z chords. So, or let's just say y is the same, so there's no verticality, or z is the same, and you just move across x and y. Then, right? Yeah. If we get a bunch of random x and y values, well, I mean, they're all going to be valid. So if we are later looping through them to reuse them, we're probably going to loop through them forever. It's never going to end. Because there's no random integer. Oh my god, another one. There's no random integer that's going to be forbidden. Oh. You guys stop. Fuck. Where's he at? Not on me. No. Get him. Oh, there he is. You're done. Can we be done, please? 9 now. Span of 35 minutes. C-style arrays should be avoided in most cases. Yeah, basically there's no super awesome, there's no perfect, mega convenient way to traverse the array and not worry that we're going to be stepping out of bounds. Yeah, I mean, that's it. There's no convenient way to avoid stepping out of bounds and ensure that we are stepping out of bounds without missing any values and shit like that. Okie doke. Oh, great. They're fire ants. Maybe. Or they're carpenter ants? These look identical, except maybe less fuzz, but I can't tell. Okay, avoid using them as much as possible. Good. String V for read-only string, string for modifiable, array for some const expression shit, and then standard vector for non-const expression. Because standard vector are resizable, whereas standard arrays are easy, never modify guy. Oh, and standard array for non-global. Oh my god, there's another. Okay, I think I'm gonna put something there. And there's a fucking another one. Bro, I don't know if I should put this in. I don't think I will. Damn, this guy's quick. Not as quick as me though, buddy. Put one down. I signed up for a fucking mini game. I don't want to put water there though, because then that might attract him. Back to it. So, global const expression arrays can be C-style, but non-global should not be. Why is that? I mean, because if anything, we can make standard arrays be inline and constant expression, so we can add them everywhere and have them be global. Not sure why we would use C-style over that right now. The linker, for some reason, more partial to them? I'm not sure. We pass by reference. But the reference will decay because it will be in there. So it's like, is that helpful? Oh, maybe. In global contexts, do we somehow want to use a pointer more than we want to use the array itself? I'm not sure. I don't know right now. Oh, don't I have tape? Yeah, but aren't they gonna eat the tape? They might. Excuse me. Must have a fixed length. Oh, that's a pain in the ass then. That doesn't work. It avoids it. Yeah, exactly. Yeah, because we already use class templates, or at least function templates, to accept a standard size, the value of which we don't know, for standard arrays. To store const expression global program data. Meaning that the pointer exists so that we can or const expression static local could go to. I mean, we still have to pass the address. But yeah, if you had the address somewhere, then yeah, you could just access the address and not worry about anything deeper. Yeah, but the syntax shouldn't be any worse though, because if it's const expression, then we're already initializing it, right? So standard array would just be literally standard array identifier, boom, initializer. See, I mean, it could be at least slightly quicker to type and not have signed conversions. I could see it. As parameters to functions or classes, I want to handle non-const expression C-style string arguments directly. A non-const expression C-style string, huh? I haven't even seen that yet. Why? Converting a non-const expression C-style string to a standard string view, meaning that if we're creating a standard string view of it, we have to traverse it, which means that would be happening over and over. So the point is C-style is still converted to standard string view, but it's a lot cheaper than converting it to a standard string. Fucking knew it, dude. I knew I could just spawn one. Bro. You're going down, son. Your top. He's up there. He's a little smaller. He's a smaller one. Bro. He's just bundled up in the corner. I don't want to stand on his desk. I want him to come a little from the wall. Fuck. I need to get a little closer to guarantee him. God, it scared me. No, fuck, he ran. Didn't he ran? He did, he ran. Fuck, I can't even speak. Fuck. He's damaged, but he ran. He got away. I fucked up. I'll be back. And there was a fucking baby cockroach in the kitchen. I love that. That big. So instead of converting two standard string views, we can just use them as is without having to without having to traverse them to get their length. To then yield the standard string, which seems like, or standard string view. Excuse me, which seems like just a C-style string, but with a length. Since string view has a dot length, but maybe not. Has a dot size. Not really sure why it's required to traverse it, but okay. If it calls other functions that expect C styles, we get repeated conversions here. Or we're saying we're converting to a standard string view just to be converted back to a C style. Okay. So array decay is the phenomenon where passing a C style, or where evaluating a C style array converts it to a pointer to its first element, the 0 element. So when you pass it as an argument to a function, the array is evaluated on that line you're passing it in. Thus, you end up passing a pointer to the first element, the 0 element. The function receives the pointer and can still subscript it, but does not get its length. So the decay refers to the loss of length information that standard vector and these other class type arrays, standard vector and standard array, both have. And it's a problem because if we need that length to avoid going outside of the bounds, we need to either pass it, we need to either change the array to pass a value that we can stop iterating, or we can stop traversing past once we reach it, or we now have to we have to get the length, and we have to pass it we have to get the length and we have to pass it with it to functions now. Yeah. They use a null terminator as the second solution, so instead of passing their size wherever they get used, they're instead modified in their structure. They have a null terminator character at the end so that when we traverse them, we stop when we hit the null terminator. True, and we can also traverse them and count how many traverses we've done until we hit the null terminator. Why do they use a null terminator? instead of requiring both the decayed stuff? Well, it's two options. One could be that maybe we don't know. Well, one could be let's see. One, it's a bitch to have to pass it, the array and its size, everywhere it's going. I'm trying to think if there are compile time implications. I mean, if it's non-const expression and it's created at runtime, and the function receiving it, but then it would have to exist at compile time anyways for the function to require it to. So I was gonna say if the size isn't known at compile time, then some functions might not be happy. But those functions wouldn't be happy anyways because the rest of the array wouldn't exist at compile time either. So seems like it's just two different strategies. What's another shortcoming of passing the size with it each time? I mean, it seems like it's an efficiency thing. So instead of just adding something to the array and evaluating it once each time we pass it, we basically just traverse the array until we hit something. And once we do, we stop. Instead, if we pass the size, especially if it's non-const expression, maybe the size changes. In that case, we may as well use a standard vector whose size we can get easy peasy, and we can resize it. The ergonomics would be horrible. We'd have extra parameters and magic numbers everywhere. Yep. Or it'd be standard size of hello. For the string and the provided string length to not match properly. Because the string length should match the actual length of the string, should be the length of the string. But then the user has to match it instead of it automatically being matched. I imagine standard vector, the invariant is always preserved because when you call the length, it probably traverses the array to get the length. Even if CFS wanted to implement having to pass explicit type or length information, why wouldn't it work? Wanted to implement having to pass explicit length information? I mean, we could always just loop through it. I mean, it seems like it's the same answer, kind of, huh? Oh, duh. Operate in cases where we're using... In cases where... What about cases where we're passing it, but we aren't explicitly providing it? Like an operator overloading for standard character output, where we have the insertion operator in our right-hand operand, the string. Well, there's no third operand to pass the length. There's no way to get the length to where it needs to go. It only happens if we're... Oh, he's back! It only happens when we're calling it explicitly, but if it's called implicitly... Okay, he sent fucking reinforcements. It's a big man with Gemma. Oh my god, he's going major fast. This guy's a Super Saiyan. He's going quick. What's he doing? On the ceiling. I want to sponge him or something. I need a better tool. No more paper. What should I use? Don't know. I'm not gonna burn him. Jesus. Just trying to. Oh my god. More. Go. Oh, this feels like it's not enough paper. You're done. Fuck. He's in that weird spot. Done too, buddy. Two more. There you go. Bro, fucking. This is gonna get annoying. Alright, can I get a break? I don't want any more. I'm gonna check my email just in case. Okay. So yes, the other was in operator overloading. If it's called implicitly, meaning that we use an operator and the operator is the function, standard character output, C string, the binary operator can only take two operands. There's no way to pass another for the length. Whereas changing the actual structure of the string itself lets us pass the, well, not pass the length, but lets us get the length basically. Oh, another from down below. You're done. Arrays are stored sequentially in memory. Yep. Bop, bop, bop. Yep. How arrays indexing math work. How array. Oh, well, it should be how array indexing math works. How range-based for loops work. Okay. Addition, subtraction, increment, decrement to a pointer to get what, the next place? Yeah. Makes sense. Oh, next object in memory. If pointer is a pointer to an integer, adding 1 points to the next integer probably. If it is 4 bytes, it will return. Hold. Oh, +1 will return the memory address that is 4 bytes later versus 8 bytes later for 2. So the next object in memory. I mean, that assumes that there is an object there, but I guess you assume that there is. So, okay. That is 8 bytes after pointer. So we have index. We create a pointer to a constant integer, and we probably give it x's address. We do. We output pointer, and then we output pointer +1, and then pointer +2. And I imagine we're going to see differences of 8, 0, 4, 8, indeed. Also works with subtraction to go before, which would be interesting. I mean, I guess you'd only do that once you already go later. So you're not stepping too early in bounds. You don't want to go before the 0th index, probably. Unless you're really able to micromanage your memory. I don't know though. Makes sense. So we get that, and we get pointer -1 and pointer -2. So we get 0, and then C for what? 12 or something, or 13? Or no, 12. That's 8, 9, A, B. Okay. Oh yeah, because it's 8, so it's 9, A, B, C. Okay. And C, D, E, F, 0. Because F is 15. Okay. 4 less than the previous. Makes sense, yep. Like, I don't know what caused the ants, but I'm hoping that they don't take over this fucking room while I'm asleep. The address of the next previous object. So doesn't that mean we get some skippage going on? Well, I guess if we're saying the next address. I think in terms of object, we're referring to the collections of memory that represent an object. But if there isn't actually a standard string there, like let's say we have a long unsigned int, okay? So we have an 8-byte integer, 8 times 8, 64, we got a long. Okay, it doesn't matter if it's unsigned or not. We have a long. And we get the address of it and initialize a pointer, but then we add +1 or subtract 1, we're going to get +8 and -8, regardless of whether the next thing is actually an unsigned int or not, or the previous thing is, or is a standard string or not, because it's probably not. It's just how that memory is being interpreted. So it'll assume that everything is a long or a standard string. So we can get to the next clump of memory or back to the previous clump of memory by adding or subtracting. Okay. All right, hold. But actually modify the address held by a pointer? Wait, hold. Well, yeah, because if we increment the pointer, doesn't that mean it's just setting the pointer to be? Yeah, exactly. Makes perfect sense, yeah. Yes, we have x. We could increment pointer to be pointing at the next object, and then decrement pointer to be pointing at the previous, which would be x again. Yep, boom. Yeah, it's undefined behavior because if we increment it and don't know what's in front, unless we're talking about a C-style array where we're incrementing the evaluated pointer to then point to the second element, well, it's undefined behavior, bucko. It's only defined when the pointer and result are within the same array. Yeah, exactly. And in this case, we don't have another array. So subscripting is implemented via pointer arithmetic. Yeah, that makes sense, because to me it sounds like if you're evaluating the pointer, then you're basically evaluating the pointer subscript 0. Or rather, if you use the pointer subscript 0, you're dereferencing whatever the pointer is pointing at. You're adding whatever the number is to the address, and boom. So you're saying 0, you're not adding any object. You're not going to the next object or the previous, so you're evaluating the one you're already pointing at. Boom. But if you do subscript 1, you're now adding 1, just like you would be looking at the second element of the array. You'd be pointing to this guy, but you're adding 1, so you're now looking at the next one. Boom. Excuse me, and then dereferencing to get it. That subscripting can work with pointers, okie doker. A normal pointer holding the address of element 0. Get the second, so we get 5. Let's see what answer attracts you. Yeah, let's just see. Warmth, moisture, electric fields. God damn. Motherfucker, it's probably cooler in here. Okay, so I clutched up by not putting that wet shit there. What, the pheromones are electric fields? Really? Okay. I fucking told your ass. It's exactly what it looks like. Boom, boom. Concise syntax. Yes, exactly. Because it's pointer plus this, and then dereferencing that entire thing. Yes. Pointer arithmetic with some extra stuff. Cool. And an implicit dereference. Yes. Here. To get the object. Yes. Yep. Decays into the guy holding the address of the 0, but then we add to look at the next one. So we're looking at 2 later in this case, because we're doing 2, not 1. We're looking 2 later, which is pointer plus 2 to look 2 objects later. Click, click, and then dereferencing it to get that value. So it's click, click, or no clicks, click, click. Yep. Fucking hairs, dude. For example, array 3, 2, 1. Yep. So we're doing output in the address of array 0, or well, output in the address of 0, 1, and 2, and then we're outputting 0, 1, and 2, and then we're outputting array plus 1, array plus 2, and then that dereferenced. Yes, yes, same shit. Subscripting is just a convenient way. Yes, exactly. Yep, yep, exactly. If we raise the pointer to that element, array plus something will return that element. Yeah, exactly. Makes sense. 0 base instead of 1. Yeah, because otherwise, if we said they were 1 based and we did 2, it wouldn't be adding 2, it'd be adding 1. So it'd be, yeah. Compiler converts that into pointer plus whatever. When subscripting, it means that we can also subscript a pointer as oh, what are you saying? So we can do pointer subscript n, and it evaluates to pointer plus n, and then dereference. But we can also subscript it as n with the subscripted pointer. Why though? Why does it do that? Is it just because of operator overloading? The point is all it's doing is adding them together, so it doesn't matter because it's commutative. 3 plus 2, 2 plus 3, same shit. Pointer arithmetic and subscripting are relative addresses, meaning relative to what, the origin, relative to some point. Meaning that if somewhere else accessed that same address, it wouldn't work. The index represents a fixed element within the array. It's an illusion. Array indices are actually relative positions, meaning if pointer's pointing to element 0, that will get the next element. But if it's pointing to element 3 for some reason, and then we do subscript 1, it's not going to point to the first part of the array. It's going to point to one later than the pointer, because C style, or in this case, or I guess pointers in this case, we're talking pointer arithmetic. All it's doing is adding 1. Okay, makes sense. So if we had another pointer in here, the pointers we're going to do, yeah, see, we're going to do element, or we're going to do 0, but it's not going to be, it's going to be printing the object at the pointer, because it's going to be printing the pointer plus 0. So no other memory address, it's just the one that it's already looking at. It's the one it's already holding and printing that one. For example, we have array. This is now a pointer to the first element, the 0 element. Okie doker. Then we say print pointer, and then this. We get the same thing, same thing. We print, we dereference pointer plus 1, and then this. We get the same shit. Boom, boom. But then we say pointers now instead the array's fourth element. Here it is, 6. But then we do pointer 0, we still get 6. And then we get plus 1, we get the last one, we get 5. There's another. I have no clue where he came from. I mean, it's got to be some electric shit, right? Oh, he's a teleporting one. I need him to go into another spot. There you go. It has to be all the electronics in this corner. Oh, there was one I was missing earlier. Nice. I'm tempted to wipe the wall to get rid of their scent trails, but I don't really want to fuck with anything. It's a lot more confusing if we can't assume that that is always the element with 1. Yeah, it makes sense, which makes sense that they're fucking annoying, where we would only use this with an array, yeah. And only do it when we're talking about the start. Because otherwise we may as well just do pointer plus 1 and then dereference, right? It seems like that makes more sense. Pointer arithmetic for relative, or subscripting for from the start. Pointer arithmetic when doing relative shit. Or, oh damn, no questions on this one, shit. Alright. Favor subscripting when indexing from the start. Oh, sorry. This should be for CPP. Alright, that's it for now. More tomorrow.